Chapter 2 begins our discussion on organizing our data. We're going to look at taking our data and turning it into different types of tables and also different types of graphs. And all of them have their strengths and their weaknesses, depending on what we need. Let's start out by defining raw data. Raw data is data collected in its original form. So here's an example of a bunch of drive-through service times for McDonald's at lunch. So we have cars coming through the McDonald's drive-through, and these numbers are the seconds that it takes from when they place their order to when they pick up their food. This is an example of raw data. What's going on? There are a lot of different numbers, and it's really hard for us to make sense of these numbers. It's hard to understand what's the most common time. You would have to sit and sift through all of these numbers to find the longest time it took or the shortest time it took. We're going to talk in Chapter 3 about different types of averages. So being able to find an average might help us, but there are so many numbers. What do? One thing that we can do is something called a frequency distribution. A frequency distribution is a type of table that organizes the raw data. And there are several different types of frequency distributions. We're going to be looking at all of them. A categorical frequency distribution, a grouped frequency distribution, a relative frequency distribution, a cumulative frequency distribution, and a relative cumulative frequency distribution. So let's start out with the frequency distribution. So generally, a frequency distribution is organizing raw data in a table using classes and frequencies. So let's start with our ungrouped or categorical frequency distribution. A categorical frequency distribution is one that we can place the data into specific categories. So generally, this is nominal or ordinal level data. Classes, nominal, we can only put them into groups. Ordinal, we can order them, but the differences between them are meaningless. Or some very simple interval or ratio level data where the data values are small. So in this example, we have a 6-sided die. We only have 6 numbers that we can get. And here we've rolled the die 900 times. Likely we haven't really rolled the die 900 times. We've either had a bunch of people roll it or we've simulated it using a computer. And there are some really nice simulations that we can find on the internet that will show us how we can roll a die 900 times very quickly and get this data. We may have a lot of data, but the data values only take on a certain limited number. So ungrouped or categorical frequency distribution is a frequency distribution that we use for data that can be placed in specific categories, hence the name categorical. We're talking about nominal or ordinal level data or interval or ratio data with a limited number of values. And so here with our die, we have ratio level data and our numbers 1 through 6. There's a definite difference between them, and a 0 would mean we didn't roll the die at all. We can say that 4 is twice 2, and that's what gives us that ratio. We're allowed to make that jump, and it makes sense. So here we have our classes represented in the left column, and we have our frequencies or our counts represented in the right column. Sometimes the table will have a total, and sometimes it won't. The total isn't mandatory in that sense for a frequency distribution. A lot of times it's convenient and it helps us in the long run with some decisions, but sometimes we have to come up with that total ourselves. So that is something that we will be looking at. How do we find the total? What does that total mean? Because it is important when we talk about calculating certain things in Chapter 3. And so there's an example of our categorical frequency distribution. A class, it's a categorical or quantitative category. So we're still talking that same language from chapter 1 of categorical or qualitative data versus quantitative data. And then still these levels of measurement. So we're still taking on that same vocabulary from chapter 1. And so here we can see the classes are the numbers on the face, but we can have different types of classes. So a class in general is a categorical or quantitative category. You could think of it as a label, in a way, on the table. And then the frequency is the number of data values that are contained in that class. So if I look back up here at the table, when I identify 148 here, this means there were 148 rolls of the number 3. So 148 times out of those 900 rolls, we rolled a 3. So the frequencies are the counts. How many times did you roll a 3? 148 times. How many times did you roll a 5? 158 times. So this is one type of frequency distribution, our categorical frequency distribution. Our next type of frequency distribution that we'll look at is our grouped frequency distribution. This one takes a little more time to create, and it's used for a large set of numerical data with many values so that the data are grouped together. Instead of looking at individual numbers, now we look at a range of numbers. So between 75 and 124 seconds, for example. So where all the values that are between 75 and 124 would go into that class, into that group. So let's write this definition down. Grouped frequency distribution we're using for a large set of quantitative data. And remember, quantitative is just a fancy word for numerical. And by large set, I really mean data with many different values, more than the number of data values that I have. And it's called grouped frequency because the data are grouped or classified together. Even though they may not be exactly the same number, they're close enough that we can group them together. Okay, some more definitions that come with grouped frequency distributions. I'm going to write down the definitions and then work through an example. So this raw data for the McDonald's lunchtime, it's up here because we're going to use that data to actually create this grouped frequency distribution together. So I can show you step by step how to create it from raw data. All right, so looking at all of these definitions here, from the lower class limit, upper class limit, class boundaries, class width, and class midpoint, all of these are for that grouped frequency distribution. So again, I'm going to give you the definitions and then show you what I mean by them when we do the frequency distribution together, okay? The lower class limit is the smallest data value included in the class. The upper class limit, you got it, it's the largest data value included in a class. Class boundaries are used to separate the classes so there are no gaps in the frequency distribution. This idea of class boundaries is very much related to the boundary values that we talked about in the first chapter. The class width is ultimately the difference between the two classes. How wide is each class? And there are 3 different ways to calculate the class width, but all of them are going to result in the same number. So I say that it can be calculated 3 different ways because we can define the class width 3 different ways. So here we go. The first way to define class width is the difference between successive, which means right next to each other, lower class limits. The second way is successive upper class limits difference. And the third way is the upper and the lower class boundaries. So for a single class, we subtract upper class boundary minus lower class boundary to get our width. All 3 of these will give us the exact same number if we've constructed the frequency distribution correctly. And then our last definition for this grouped frequency distribution situation is that of a class midpoint. The class midpoint sometimes is represented by a capital X with a small subscript M next to it. And the class midpoint is calculated by averaging the upper and lower class limits, or also class boundaries. And averaging just means add them up, divide by 2. So we could take the upper limit plus the lower limit and divide by 2, and that would get us our midpoint. I am not going to create this grouped frequency distribution just yet. I want you to skip for a second, because we need some rules or some suggestions for creating these group frequency distributions. Let's talk about that first, and then we'll go back and construct it. Let's skip creating the group frequency distribution for now, and let's look at it and start identifying the parts, because I think that would be important to identify each part and you know what's in the table, and then we'll go back and create it. We want to identify class limits. These values that come first, these are all our lower class limits. The values above are our upper class limits. For our class boundaries, the class boundaries are going to come between the classes. They are boundaries. So let's look at between the first class and the second class. So I'm looking here at this one first. I want to know what number comes between 124 and 125. What number is perfectly in the middle of 124 and 125? Or, if we turn it around and talk about our boundaries, what's the upper boundary for 124 or the lower boundary for 125? Referring back to what we talked about in chapter 1 with boundaries. We always had one more decimal place than the value, and it ended in a 5. We want what comes smack in the middle between 124 and 125, and that boundary will be 124.5. It's the smallest number that rounds up to 125, and everything up to that number will round down to 124, and that's what makes it our boundary. So then how do you find the boundaries for the other classes? What's the boundary for the values 174 and 175? Right, 174.5. How about the next one? 224.5. Remember, I'm looking at, to find the class boundary, I'm going to try to use some colors here. I'm looking at the lower class limit of one class and the upper class limit of the previous class. So if I look at 174.5, I'm looking at 174 and 175. If I'm talking about the 224.5 boundary, I'm looking at 224 and 225. I want to know what number comes in between these classes. How about this one, looking at 274 and 275 here? 274.5. Good. Okay. Now, how do I get these other ones, the one that starts it all off and the one that ends it? Well, think about those boundaries back from chapter 1. What's the lower boundary for 75? Right, 74.5. So 74.5, I'm only looking at that number. And then how about the upper boundary for 324? 324.5. So these are my class boundaries. Awesome. We can see the frequencies here listed. That's all good. Now we need to calculate the class width and the class midpoints. Remember, is going to be the same for every single class. We only have to take 2 classes and work with the 2 successive classes. We can see that it'll work for all the rest of them just by a quick check. So for class width, we'll look at calculating the difference in the lower limits. And remember, difference just means subtraction. Successive means next to each other. So successive lower limits. Let's take 125 and 75. We'll take the second class and the first class. So 125 minus 75 would give us 50. Try it out on your calculator. If you can't do it in your head, it's perfectly fine not to do it in your head. So 125 minus 75 will give us 50. If we look at the difference in successive upper limits, we can look at still the first 2 classes. So 174 minus 124 and we get 50 again. Now, before I go farther, a reminder. I am doing this 3 different ways to show you that it can be done 3 different ways. When you have to calculate the class width, you only need to do one of these. But I like to show you that all 3 of them work so that you know you have options. For some of you, you're going to like one way better than another. Go with that way. I'm showing all 3 to show you that it can be done. And the third way possible that we have is the difference in the boundaries. And so for the class boundaries, we could take, let's jump around and see if it still gives us 50. Let's take 274.5 minus 224.5. And we'll grab that calculator, 274.5 minus 224.5. And we get 50 again. So our class width is 50. All right. And then the last part is our class midpoint. For our class midpoint, now notice with the class width, we're taking successive lower limits or successive upper limits. For the class width, we never take values in the same class. We're not doing 124 minus 75. We're doing 125 minus 75. Successive lower limits or successive upper limits or the class boundaries. When we do the midpoint, however, we're focused inside a single class. For the class midpoint, we're going to have 5 different midpoints, one for each class that's in our table, and we'll take the class limits, add them together, and divide by 2. We want to find the number in the middle of our set. So for the first class, we have 75 plus 124 divided by 2. And with our calculator, 75 plus 124, make sure you hit equals first and then divide by 2, 99.5. Let me show you what happens if you don't hit equals first. Clear this out. 75 plus 124 divided by 2. The calculator does the division first. 124 divided by 2 and then add 75. It's using the order of operations. Multiplication and division come before addition, unless you force it to do the addition first. We want it to do the addition first. Notice my parentheses there. I want the addition done first and then divide. So we need to make sure when we're using our calculators, we are using them correctly with our order of operations. Add first, hit equals, then divide by 2, and we get our midpoint. Let's do that for the remaining midpoints. We'll have 125 plus 174 divided by 2. 175 plus 224 divided by 2. And we calculate these. Take your time with it. Use your calculator. For this second class midpoint, we'll get 149.5. For the third class midpoint, we get 199.5. And we can continue on with the other two, but I want to show you something else that's pretty amazing. Even though we don't define the width in this way, it actually turns out that width is almost like the framework of the entire table. Because if I take 99.5 and I add the width to it, I get 149.5. And then if I take 149.5 and I add 50 to it, I get 199.5. So generally speaking, it's a little bit easier to add 50 to my midpoint to get my next midpoint than it is to continue to add and divide and add and divide and add and divide. To get our class midpoints for classes 4 and 5, let's just add 50. So 199.5 plus 50 is going to give me 249.5. And then 249 plus 50 is going to give me 299.5. And I can get all 5 of my midpoints that way. And so again, that class width, the reason we define it that way, the way that we do, successive lower limits, successive upper limits, or the difference in class boundaries, is because that class width basically creates this scaffolding for the entire table. The other way to calculate class midpoint is by the boundaries. The first way using the limits, and the second way using the boundaries. We'll just do this once, just so that we can see that it works. So using the boundaries, I can take 74.5 plus 124.5 for the first class and divide by 2. And let's see if that'll give us 99.5, just like our class limits will. 74.5 plus 124.5 equals, divide by 2, 99.5 again. This idea of using the boundaries also works. And again, we can still get our other midpoints just by adding 50.